Look up at the night sky. Go ahead, I'll wait. What do you see? Maybe stars, maybe a planet, or the faint glow of the Milky Way. But what you're really seeing is a window into the past. For as long as we've been human, we've stared into that cosmic abyss. We've asked the big questions. Where did it all come from? Where is it all going? Where does it end? Does the universe have a wall, a boundary, an edge you could crash into if you traveled far enough, fast enough? This isn't just a question for philosophers or sci-fi writers. It's one of the most profound inquiries about our reality. Before we dive into what NASA found, let's get our terms straight. When we talk about the edge of the universe, we're not talking about a brick wall that says, end of the line, turn back. The universe is expanding. We know this. Everything is moving away from everything else. Think of it like a loaf of raisin bread rising in the oven. Every raisin is moving away from every other raisin, but there's no single center to the expansion. So when astronomers talk about the edge, they mean the observable universe. The edge of that bubble is the cosmic horizon. For generations, the prevailing wisdom about the universe's ultimate structure fell into a few camps. The most popular idea was that the universe is infinite and flat. Flat, in cosmological terms, doesn't mean it's like a pancake. It means that on the largest scales, it obeys the rules of Euclidean geometry we all learned in school. In both the flat and open models, the universe would expand forever. The cosmos would just keep getting bigger, colder, and darker, until a distant future where all the stars have burned out, and the whole thing ends in a big freeze or heat death. All of these theories shared a common assumption. What we see inside our cosmic horizon is representative of what lies beyond it. This principle suggested that beyond our view lies just more space, more galaxies, more of the same. But NASA's new discovery has thrown a cosmic wrench into all of these elegant, orderly ideas. So, what did NASA find? Hold on to your hats. The latest data, gathered over 5 years of painstaking observation, suggests that at the very edge of our observable universe, there is a structure, not a wall, not a boundary, but something that behaves like a gigantic cosmic mirror. The mission, codenamed Echo, wasn't looking at light. It was listening for something much more fundamental: quantum resonance. And what it heard was an echo. The faint, primordial vibrations from the Big Bang appear to be bouncing off of something. Imagine you're in a concert hall. You clap your hands. The sound travels outwards, hits the walls, and bounces back to you as an echo. By timing that echo and listening to how it's distorted, you can figure out the shape and size of the hall without ever seeing the walls. You can't see the edge of the universe with a telescope that looks at light. Light just can't pass through the hot, dense plasma of the early universe, so our view is blocked by the cosmic microwave background. To peer beyond that wall of light, you need a different kind of sense. You need to listen to the universe's heartbeat. This is NASA's Quantum Resonance Imager, the QRI, aboard the Echo probe. The QRI is not a telescope. It's the most sensitive gravitational wave detector ever built, designed to hunt the faintest, longest wavelength vibrations in space-time. Think of space-time as a pond surface. The Big Bang was like dropping a giant stone, creating ripples. The QRI uses quantum entanglement. It creates entangled particle pairs, sends them opposite ways, and measures tiny changes. The engineering behind this is breathtaking. For 5 years, Echo drifted in the cold outer solar system, just listening. It collected petabytes of data. The biggest shock wasn't just that there was an echo, it was the nature of the echo. The data suggests that the boundary isn't just reflective, it's behaving like a phase conjugate mirror. This is a concept straight out of advanced optics labs, but on a cosmic scale. A regular mirror reverses an image from left to right. A phase conjugate mirror reflects a wave back along its exact original path, effectively time-reversing it. If you shine a distorted, messy laser beam at such a mirror, the reflection comes back as a perfectly clean, focused beam. This is the truly mind-blowing part of the discovery. Our universe of increasing disorder is mirrored by an anti-universe of decreasing disorder. Let's use an analogy. Imagine our universe is a movie playing forward. The new data suggests that at the edge of the screen, there exists a mirror universe where the movie is playing in reverse. The scientific community is reeling. If this cosmic echo data holds up to scrutiny, and NASA's methods are famously rigorous, it will launch a revolution in physics not seen since Einstein. The idea of a mirrored phase-conjugated boundary to the universe isn't just a new detail, it's a completely new foundation. For instance, the puzzle of dark energy. This is the mysterious force that is causing the expansion of the universe to accelerate. What if dark energy isn't a force at all, but is related to the interaction between our universe and its time-reversed twin at the boundary. The questions this raises are almost overwhelming. For scientists, this is the beginning of a new era. Decades of theoretical work will be re-evaluated. New experiments will be designed to verify the QRI's findings and to probe this boundary in more detail. So what does this all mean for us, here on our little blue dot? On one level, nothing changes. The sun will still rise tomorrow, but on a deeper, more profound level, everything has changed. We have always felt a certain cosmic loneliness, but this new picture, while incredibly strange, is also strangely comforting. It suggests balance, symmetry, profound connection. This discovery is a powerful reminder that we should never stop asking what if. It shows that the universe is far more clever, more intricate, and more surprising than our imaginations had allowed. We build our models, we write our equations. And then the cosmos sends us a postcard from the edge. And that is the most exciting thing a scientist can ever hear. It means the adventure is not over. In fact, it may have only just begun. The greatest discoveries are still out there, waiting for us to be curious and bold enough to look for them. So keep looking up, keep asking questions. The cosmos is waiting, full of echoes, reflections, wonders we have yet to dream of. The journey into the unknown continues, and the view is absolutely mind-blowing.